Hey guys, this is section 11.5, alternating series, video 1. So first up, what is an alternating series? Well, technically you have already seen examples of these. I know for sure in the previous section, 11.4, but possibly in 11.3 as well. I can't remember. But basically it just means a series where every other term is positive or negative, depending on which way you want to look at it. So the terms go back and forth between positive and negative, literally alternating. So it has its own special section just because there's a theorem just for alternating, or a test rather, just for alternating series. So on this page, we have just a couple of very basic examples. The first one is your standard series of 1 over n, but it's been made alternating instead. So it starts out positive and then goes back and forth between negative and positive. And then the second example is n over n plus 1, but alternating where the first term is negative instead of positive. So notice one of the big differences outside of the terms themselves between these two series is that the top example has -1 raised to the n minus 1, and this bottom one is -1 raised to the n. So what's the difference? Well, it's all about whether you want your very first term to be positive or negative. So in this top one, when n equals 1, we would have -1 raised to the 1 minus 1. Well, 1 minus 1 is 0, so we'd have -1 raised to the 0. Anything raised to the 0 is 1, therefore this is positive 1, which means your first term is positive and then you start with the negative terms. In this bottom series, when n equals 1, we'd have -1 to the first power, so of course the first term is negative and then positive. So if you see an n minus 1, that implies that the first term is positive, and if you see an n, that implies the first term is negative. But both of these are alternating series. Okay, and this first part here is just what I was explaining. We typically write, or we try to write, alternating series as the -1 raised to a power being separate from the rest of the term, just because it makes it easier to analyze. So Bn is always assumed to be a positive number, and then -1 to the n minus 1, or n, is the alternating part. And those two multiplied together make up your actual terms of your series. So what is our test for alternating series? If the alternating series sum of n equals 1 to infinity of -1 to the n minus 1 times Bn, if we have an alternating series and it satisfies two conditions, the first one being that the series is decreasing, the positive part of the series, I should say, the terms are decreasing. So Bn plus 1 is always less than or equal to Bn. If you read this backwards, it might help you understand it a little bit better. Bn is greater than or equal to Bn plus 1. So basically each term is getting consecutively smaller if you ignore the negative and positive signs. And then the second condition it has to satisfy would that the limit of the positive portion, Bn, is 0, as n goes towards infinity. If both of those are true, then you can say that your series is convergent. If we go back to the previous slide, it sort of summarized this in clear English. If the terms of an alternating series decrease towards 0 in absolute value, then the series converges. So this first statement is saying that they're decreasing, and a second statement is saying that the limit of Bn is 0, then the series is convergent. So again, we saw an example exactly like this. I think in 11.4, it might have been in our Zoom session Tuesday night. Either way, writing out the terms of the series can really help you understand what's happening here, but you can kind of ignore the alternating piece and just focus on the positive portion. So let's try to use it. Let's look at the alternating harmonic series. So 1 over n is our b sub n term, and then it's alternating, -1 to the n minus 1. Since that power is n minus 1, that means we're starting with a positive term. So you can see that this series looks like 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5, minus 1/6, and so on and so forth. So we have to ask ourselves, is it decreasing, and is the limit 0? So first of all, we can analyze, are these terms, again, you ignore the negative positive, are these terms decreasing? Well, yes, because 1 over n plus 1 is less than n. Where did these come from? Well, Bn here is 1 over n. So in order to check if this is satisfied, we simply plug in n plus 1 and n to see what that inequality is. But looking at the terms itself can be a little bit easier. Is 1/2, I'm sorry, I'm saying this backwards. Is 1/3 less than 1/2? Yes, it is. Is 1/4 less than 1/3? Yes, it is. Again, you can read it backwards if you want. Is 1/2 greater than 1/3? Yes. Is 1/3 greater than 1/4? Yes. Is 1/4 greater than 1/5? Yes. You have to check this test. Are these terms decreasing? If they are, then we can look at number 2. What's the limit of 1 over n, ignoring the alternating piece? Well, we already know from talking about limits that the limit as n approaches infinity of 1 over n is 0. So because both of these conditions have been satisfied, then we can say that this series converges.